In this video, we'll discuss the Pythagorean theorem, the distance formula, and the midpoint formula. Just as a refresher from our last video, let's make sure that we can graph a nonlinear function using a table. We started with linear functions, but it doesn't matter what kind of function you have, you can always make a table. So if I choose values for x and y, then I should be able to solve for the corresponding part of the ordered pair. So for example, if x is 0, I'm going to get y equals negative 0 squared plus 5 and get 0, 5. So let's plot that here, 0, 5. If I let y equal 0, this would be my other intercept. I'm going to get minus x squared plus 5. I'll subtract 5 from each side. I will divide by negative 1, so I'll get 5 equals x squared, and then I will take the square root of each side. Now when I take the square root, I have to take both the positive and the negative square root of 5. So I actually get two values here. If y was 0, I get root 5 or negative root 5. And root 5 is a little bit more than 2. It's 2.23. So I'm going to go 2.23 here, 2.23 in this direction as well. And what we notice, if I could do a couple more, let's do 2. If I plug in x is 2, I get y equals negative 2 squared plus 5, which is negative 4 plus 5, which is 1. So if I go 2, I'll be at 1. If I plug in negative 2, not much different here. We're also going to get 1. So at negative 2, I'll be at 1. And you can see that this is turning out to be a little bit of a U shape. And if you can't see it, you just plot more points. Now, what we want to talk about is the Pythagorean theorem. The Pythagorean theorem says for all right triangles, it has to be a right triangle, which means it has to have a 90-degree angle. It is always true that a squared plus b squared equals c squared, where a, b, and c are the lengths of the sides, and c is the hypotenuse. The hypotenuse is always the longest side. So sometimes rather than saying a squared plus b squared equals c squared, I like to say leg squared plus leg squared equals the hypotenuse squared, just in case they're labeled differently. Okay. So let's take a look at this example. If Matt drives 6 miles directly east from his house, so we'll put his house right here, and he travels 6 miles directly east, so we'll call this 6 miles, and then he turns left and goes 2 miles directly north. If there was a road directly from his house to his destination, how much shorter would his trip be if he took the straight line road? Well, that means that what we don't know here is the hypotenuse. So we're going to use the Pythagorean theorem. Since he's going east and north, we know this is 90 degrees. And we're going to say 6 squared plus 2 squared equals x squared. 36 plus 4 equals x squared. 40 equals x squared. And so x is the square root of 40. Of course, we can simplify this. This is 4 times 10, so we would write 2 root 10. So this is 2 root 10 miles, which if we put that in our calculator, we get about 6.32. And then we have to answer the question. So I always recommend going back, looking at the question. How much shorter would his trip be if he took that straight line road? Well, if he goes east and then north, that's 8 miles. 6 plus 2 would give us 8 miles. So if we say 8 minus 6.32, we're going to get 1.68 miles shorter. So we've answered the question. All right. That's how we would use the Pythagorean theorem. Now, the distance formula. The distance formula is another way to find the distance between 2 points, and you'll notice that it's very, very similar to our Pythagorean theorem. Because if we have 2 ordered pairs, let me plot some ordered pairs here. Let's call this one x1, y1, and let's call this one down here x2, y2. So a first ordered pair and a second ordered pair. If I want to know this distance, then I can find a vertical distance and a horizontal distance and get this right triangle. So what I would want to do is find this distance, which is x2 minus x1, from x1 to x2, and then over here this is going to be y2 minus y1, and then we use the Pythagorean theorem, which is leg squared plus leg squared equals hypotenuse squared, and then we just take the square root. So this is where the distance formula comes from. The midpoint formula, on the other hand, is just the average of the x's and the average of the y's. So you're going to add them together and divide by 2. And it is a point, so it should be an ordered pair. So let's take a look at a couple of examples. Let's find the distance and the midpoint between the following 2 points. So starting with the distance, we're going to say, let's call this one x1, y1, and this one x2, y2. And if we use the distance formula, we're going to say the difference of the x's, so 5 minus a minus 4 squared, and 6 minus a minus 3 and then we'll simplify. So our distance is the square root. 5 minus a minus 4 is 9, so 9 squared. 6 minus a minus 3 is also 9. So 81 plus 81, or the square root of 162. Let's think of that as 81 times 2, because 81 is a perfect square. So if I take the square root of 81, I get 9, and I'm left with the square root of 2. So that is the distance. If you wanted to know an approximate distance, you put it in your calculator and you get about 12.7. But that is an approximation, not an exact value. We always like the exact value if we can. And this says round to 3 decimal places, so 728.728. Okay, visually, let's see what that looks like. If you have the points -4, -3, and 5, 6, we notice that this distance is 9, and this distance is also 9, and this distance here we found to be 12.728, or 9 root 2. So in the worst case scenario, you could draw your picture and then just count from one x value over to the next x value. Now, the midpoint formula, much easier to use, is again just the average of the x's and the average of the y's. So in this particular case, we've got our ordered pair. We want to remember it is an ordered pair. So we're going to add the x's, -4 plus 5, and divide by 2. And we're going to add the y's, -3 plus 6, and divide by 2. And simplifying, we get 1/2 and 3/2. So let's take a look on the graph again. If we go 1/2, 3/2, we'd be about here, and that does in fact look like the middle of that line. That concludes this video on Pythagorean theorem, midpoint, and distance.